You've just learned how to use the Pythagorean theorem, and now we're going to apply the Pythagorean theorem to help us find the height of a triangle if word problems don't give it to us. So go ahead and title your notes Finding the Height of a Triangle Using the Pythagorean Theorem. Okay, so in some area problems, the height of a triangle will not be given to you. But do not despair. You can actually use the Pythagorean theorem to help you find the height of certain triangles. Okay, so let's write that down. You will need to calculate the height for yourself using the Pythagorean theorem. So I'm going to do a couple of examples, and then I want you to try some problems in your packet. Okay, let's try some examples where we have to find the area of triangles. The first example that we're going to look at is an isosceles triangle. And remember, isosceles means that two sides of the triangle are equal. Note, this picture is not drawn to scale. So we have two sides that are equal to 5 and one side that's equal to 8. And if you remember, in order to find the area of a triangle, you do 1/2 times the base times the height. We have the base right now, but we don't have the height. But we can use the Pythagorean theorem to help us figure out the height of this triangle. So I'm going to go ahead and draw in the height. And remember, we learned that the height has to be perpendicular or create a 90-degree angle with the base. Okay, I'm going to draw in the height. And this isn't perfect. So, in an isosceles triangle, if you draw the height or the perpendicular bisector down to the base, you're splitting the base here in half. So each of these becomes 4 and 4. And so now I'm just going to look at this half of the triangle. I'll go ahead and circle it so you can see what I'm talking about. Okay, so now this becomes a right triangle. Put a little square there to indicate that's a right triangle. We know that this side is 5, and we know that this side is 4, and we're trying to find this side, which I'll just go ahead and write as x. Okay, so we learned that we could find this extra side, or this other side, using the Pythagorean theorem, which, as a reminder, is a squared plus b squared equals c squared. And remember, c is the hypotenuse and a and b are the other sides. So my first side we know is 4, so I'm going to go ahead and plug in 4 for a. We don't know what b is, but we know that we're using the letter x to represent b. And then c, the hypotenuse, is 5. So now I'm going to simplify and solve for my missing side. So 4 squared is 16. We don't know what x squared is, so I'm going to leave it alone. And we know 5 squared is 25. So I'm going to go ahead and solve for x. So I'm going to subtract 16. Subtract 16. I get x squared equals 9. And remember, to get rid of this square, we do the square root. So square root of that and square root of that. So x squared, take the square root, just becomes x. And square root of 9 is just 3. So our height is 3. To find the area now, we have to do 1/2 times the base times the height. Okay, let's figure out the area. 1/2 times the base, and the base we see is 8. And we now found the height of the triangle, which is 3. And so we're going to multiply it by 3. And when you multiply all these things together, you get 12 as your area, or 12 square units. And that's our answer. Example number 2. So find the area of the following scalene triangle. And remember, scaling means that all the sides are different lengths. Go ahead, pause the video, copy this problem down, and then when you're ready, play it again, and we'll go over the problem together. Alright, so we're told to find the area of this triangle. And as a reminder, area of a triangle is equal to 1/2 the base times the height. And unfortunately, in this case, we don't know the height of the triangle and we don't know the base. So let's go ahead and try to find the height first. We're going to bust out our Pythagorean theorem here to find the height. And then we will use our Pythagorean theorem again to find this other length. Alright, so remember, the Pythagorean theorem is a squared plus b squared equals c squared. So a squared plus b squared equals c squared. To help me find the height, I'm going to simply use this left side triangle right here. Okay, I'm going to go ahead and redraw it so that it's easier to see everything. It's a right triangle, so we can use the Pythagorean theorem. And remember, C matches up with the hypotenuse, and A and B relate to the different sides of the triangle. I'm going to go ahead and plug in what we know. So we know that the first side is 11 squared, or 11, excuse me. So I'm going to do 11 squared. We don't know what B is, but we know that B is being substituted by x, so I'll put in x squared. And we know what the hypotenuse is. It's 22. So I'll do 22 squared. Now, 11 squared is 121. I'm not exactly sure what 22 squared is, but I'm going to bust out my calculator. Let's see, 22 squared gives me 484. And then I'm going to solve for x squared. So to do that, I will subtract 121 from both sides. I am simply left with x squared here. And here I get 363. And to get rid of that square, I have to take the square root. So x squared. Let's see what that simplifies to. I'm going to use my calculator again. 363 gives me 19.05. I'm going to round it to 19. And that is my height. So I'm going to go ahead and plug that in. Write it on my triangle right here. And now we need to find the rest of this base right here. I'm going to represent the rest of the base with the letter y. And we're going to now have to find this all the sides of this triangle right here. And we're going to use the Pythagorean theorem again. Alright, so here we go. A squared plus b squared equals c squared. We know that one of the sides is 19 squared, so I'll do 19 squared here. We know that another side is y, so I'll just indicate that with the y squared right here. And we know the hypotenuse is 25, so I'll do 25 squared here. I'm going to use my calculator to find what 19 squared is and what 25 squared is. So 361. And 25 squared. $625. And then I want to get y squared by itself, so I'm going to subtract 361 minus 361. We get y squared equals 4 264. And now we need to figure out what y is by itself, so we're going to take the square root. And let's see what we get. About 16.25 or 16.2. Let's round it to about 16. So I'm going to go back to my diagram. I'm going to write that back up here. So I'm going to do y equals 16. So now it makes this entire base 11 plus 16, which equals to 27. So now we have the height, which is 19 right here. And we have the base, which is 17, and now I can use my area formula to figure out the area of this triangle. Alright, area. I'm going to write the formula again down here. And I'm going to go ahead and plug in all my different values. Equals 1/2 times the base we saw, or we figured out was a 27. The height was 19. So I'm going to go ahead and multiply 27 by 19. I get 513. I still need to divide by 2. So 513 divided by 2 is 256.5. And that is my area. And since there aren't really any given units, I'm going to just say units squared or squared units. Alright, so now go ahead and try problems 1 through 12 on page 29 and 30. And then it's okay, just try your best. We're going to go over the answers when you come back to class on Monday. So again, that's page 29 through 30, problems number 1 through 12.